All right. Hello, everybody. I'm recording section 9.3, trig function. So this is section 9.3. I really want you to get an understanding of what you guys are learning here. It's technically 4 different numbers that you have to memorize. And then you just put positives and negatives to it, which I could tell you just to memorize it. But if I explain it to you and have you work it out, then you have a much better understanding of what you're doing. And in speaking to my TA, who is slaying Calc BC right now, you need to know these like this, like your times tables, right? You need to know them. You don't, if you're going to try to, and it's really in Calc AB. So if you're only going to do like the first part of it, then, and if you do it in college, you have to know your trig functions. So let's start off with a little bit of review. Special triangles. So I made this, it's not perfect. I tried my best, but so this one is which special triangle? 45, right? 45. All right. So in special triangles, what are the legs? X. What's hypotenuse? X rad 2, right? X squared 2. Okay, you got to know those. No questions whatsoever. Okay, 30, 60, 90. The one that's across from the short side, which is 30 degrees, right? This one's 60. This one is what? This side is what? This leg is X. What's the hypotenuse? 2X. And what's the other leg? Okay, X rad 3. So you need to know those. Need to know them. Now, first, we're going to talk about the trig functions, and then we're going to go back and look at the trig functions in terms of the unit circle. Okay, and the unit circles means it's out of 1. Oh, there we go. Okay, so I put a little box here, and then this is where you're going to draw your picture that's in the book on page 478. And so on 478, I want you to draw, and I'll do mine too. This angle from here to here is going to be theta. This point right here, let me do it in blue. That point right there is XY, your XY coordinate. I'm going to draw a line down here to make a right triangle. Thank you. And this is going to be our radius. So I want you to refer to this diagram when we are calculating our trig functions. Now, what you need to also know, and I didn't put it on here, is the formula for a circle. Anyone know the formula for a circle?
R squared times pi.
Yes, R squared is there. X squared plus Y squared equals R squared. So this is a circle. Just like a linear equation is y equals mx plus b, x squared plus y squared equals r squared. That is the formula for a circle. Okay, so let's do the trig functions. Sine is what over what? Opposite over hypotenuse. So now let's look at this. Okay. I want you to know that from here to here, this distance from here to here, even though it's not given, I know what this distance is. What's this distance? It's the x value, right? And I know from here to here, I already know that distance too. What distance is that? It's the y value. That's how you get this point. the x, y. This is always going to be the x distance, this is always going to be the y distance. Okay, let's go up to the sine. Sine of theta. Opposite over hypotenuse. Okay, so opposite, which is going to be y, over the hypotenuse, which is we're going to indicate by r, because the hypotenuse is always going to be the radius. Sine, cosine is going to be adjacent. So what's adjacent to it? Which value? The x value, good, over the radius. And tangent is opposite, which is always y, over adjacent, which is going to be x. And what's important here to know is x cannot equal 0. Okay, now, how do we get the cosecant, secant, and cotangent? Okay, so we flip them over, right? So this one's going to be r over y, this one's going to be r over x, and this one's going to be x over y. And these are good. You need to know that y cannot equal 0, x cannot equal 0, and then y cannot equal 0 in this case. Now, at some point, you should probably, because you probably are going to lose this handout, so at some point, you're going to need to put those into your notes if you keep your notes. So we're going to evaluate a trig function, not for a unit circle, just for any circle right now. So I'm going to draw this, and it's at -4, 1, 2, 3, 4, +3, 1, 2, 3. Okay, so this is my circle. Please forgive my poor drawing here. So this is the center, right? So there's my circle. That's the point that we're evaluating here, which is -4, 3. My line looks like this. Okay, and this is theta. Here to here is theta. Okay, so you now have this point, -4, 3. If it's easier for you, label it. Now I'm going to make a triangle here because there's something we're missing. I know that this value right here is -4. This value right here is 3. Okay, so let's calculate the hypotenuse. We don't have the radius of this yet. How are we going to calculate that? Yeah, we can do y squared or x squared. Let's do x squared plus y squared equals r squared. Let's just make it even easier, right? Let's solve for r. I'll put it on this side because, so how do we solve for r? Square root both sides, right? So r is going to equal the square root of x squared plus y squared. Okay, go ahead and plug that in. R equals the square root of 25. So you find out that r is 5. Okay, if I were you, make sure you write all that down. R is 5, x is -4, y is 3. Now you can write your trig functions. Do them in this order. It's easier for me to grade, right? Sine of theta, cosine of theta, tan of theta. Okay, sine of theta, what over what? Look at your y over r, right? So y over r, which is going to be 3 over 5. Okay, good. Cosine of theta is going to be negative
Negative
4 over 5. Tangent is going to be
y over x.
y or x, right? So negative 3 over 4. Same thing. Okay, let's do the other ones. And the only thing that's difficult here is that you're going to have to, if there's a radical in the denominator, you have to rationalize the denominator. All right, easy. Once you do the first ones, the other ones are easy. What do you do? Right, flip them. So what's this one? 5/3, this one? Negative 5 over 4, and this one? Negative 4 over 3. Yeah, go ahead.
So when you get 5, is there like a reason it's not like plus or minus 5? Why?
It's just, it's because you're using distance. That's why it's squared. It's going to be the positive. You get that? Okay, so that's how to solve these. Go ahead. What? Oh, cool. Thank you. Tangent twice, cotan. Okay, that's how you find the trig functions when it's just a regular circle given the x and y. Okay, so I could cut this video since it's a little long and then separate the one because we're going to move into the unit circle now. Okay, this whole thing with the unit circle and why I drew these. So go ahead and take your handout. Now, with the unit circle, it's called unit for a reason because it's all based on what number? 1. 1, not 5. It's not called the 5-unit circle. It's called the unit circle. Okay, so that means if it's based on 1, the radius is always going to be 1. So that means we'll start with this one. That's going to be 1. Now I tried to draw the triangle as best as I could. What triangle does that look like? 45. So this is 45 degrees. And what I want you to have too as well is your unit circle out because you're going to have to superimpose, right? So what we're doing is we're figuring out the coordinates now. Last couple of days, we've done the degrees and then we've done the radians. We're going to figure out the coordinates. So it makes sense to you, not that you're just memorizing it. Ultimately, you'll memorize it, but I want it to make sense. That's why I want you guys to be here and listening to this. So 45, 45, 90. Okay, I'm going to do my work on here so you can see it. Now, since I have my formula up here, see my formula for 45, 45, 90 triangles? That means that this side is x rad 2. So look what we're going to do. This side is x rad 2. So this side is x rad 2. Okay, so x rad 2, which is the hypotenuse, in this situation here equals what? 1. Very good. Now let's do some baby algebra. How do I solve for x? And you don't need a calculator for this. Divide both sides by the square root of 2. So x now equals 1 over the square root of 2. However, you have learned, hopefully, from Algebra 2 first semester, you are not allowed to have a radical on the bottom. So you have to do something that's called rationalize the denominator. We're going to multiply the numerator and the denominator by square root of 2. So now my answer is going to be square root of 2 over 2. That's my x value. That's my x value here. The square root of 2 over 2. Well, I know my special triangles. If this leg is a square root of 2 over 2, this one is also square root of 2 over 2. Aha, I have my x value and my y value for this point. Oh, I should have put my work on this side. So that means my coordinate point for a 45-degree angle is rad squared of 2 over 2, comma, rad squared of 2 over 2. Oh, I made that super small. So let's flip over to your unit circle. Bam. Where's 45 degrees? Right here, right? Here's my 45 degrees. And it's pi over 4. And now you know what the coordinates are. Coordinates are rad 2 over 2, rad 2 over 2. Oh, I should have grabbed my bigger one. It's so small. Use your big one. That's a big one. Yay, you've learned it. Watch how you've learned it. Let's flip over to quadrant 2. Quadrant 2. Okay, I'm just going to draw on this so you can see it and understand it. So watch me. Watch me first. I'm going to draw it. There's my 45 triangle. Let me do it in a different color. Okay. What's my x value here? Negative rad 2 over 2. And what's my y value? Rad 2 over 2. Nice. Let's go to quadrant 3, right here. What's my x value? Negative rad 2 over 2. And what's my y value? Negative rad 2 over 2. Good job, you guys. Now let's go here to quadrant 4. This one right here. This is so messy. I'm so sorry for people online. What's my x value? Rad 2 over 2. And what's my y value? Congratulations, you guys just learned 1, 2, 3, 4 more. Ultimately, you're going to memorize it. Okay, let's go to special triangles. 30, 60, 90. What's my radius? R. But in the unit circle, what's my radius? 1. And what's my formula for special triangles for the hypotenuse? So look, 2x. I'm smart now. I'm going to do my work on this side. 2x equals 1. So what is x? 1/2. Use it as fractions, please. Now, where is 1/2 in this 30, 60, 90 triangle? Which leg is it? The longer leg or the shorter leg? The shorter leg. And my longer leg, knowing my special triangles, is rad 3 over 2. Oh, let's do our xy. What's my x coordinate for this? 1/2. What's my y coordinate for this? Rad 3 over 2. Oh, look at that. Take your unit circle. What degree is this right here? 60. Isn't it wonderful that math makes sense? I love it. And I get paid for this, you guys. This is great. Now, guess what it is in quadrant 2? Guess what it is in quadrant 3? Guess what it is in quadrant 4? Math makes sense. I wish I could make videos like that guy who's totally over the top about radians. I can't do that. Okay, you ready? Let's do the last part. We've gotten our 60 degrees. What's the last one? 30 degrees. What is my radius in the unit circle? 1. Oh, I already did the math for all of this. How wonderful. What's my x value? What's my y value? What's my coordinate point?
Red River to-
Right? So what is it for quadrant 2, quadrant 3, quadrant 4? You just learned all of the coordinates. Congratulations.